And it's important that you notice that the answer should be in terms of A. If you were to put it in terms of X, there would be an issue here because I'm asking for f of A. I'm not asking for f of X, right? The prime of X. So that will impact what happens here. So let me just show you. So it'll be the limit as h goes to 0, and it's going to be a plus h minus f of a all over h. Does that make sense to everyone? So I'm going to get 2a plus h squared minus 3a plus h plus 2 minus 2x squared plus, oops, that should be in terms of a. Say it to you guys and then I make a mistake. That's awesome. 3a minus 2 all over h, and it's the limit as h goes to 0. And so I'm going to get the limit as h goes to 0 of 2a squared plus 4ah plus 2h squared minus 3a minus 3h plus 2 minus 2a squared plus 3a minus 2 all over h. And I can see this goes, 3a goes, 2 goes. And so I'm going to even pull out h. So I'm going to get 4a plus 2h minus 3 all over h, which is going to give me the limit as h goes to 0 of 4 plus 2h minus 3, which is 4a minus 3. Cool beans? All right, a little more algebra. How about this one? Or do you guys need time to copy that?
About a minute.
All right. I'll leave that there for you, but then I'll leave the other one for people who want to start working on the next one, okay?
Could you go up, like, a little bit? So the reason that you just substitute a plus h for any time that there's x?
Correct.
Like for just step 2?
That's function notation, yes.
Okay.
Will we get points taken off if we interchange the x and the a because we're not paying attention?
Yeah.
Okay.
Yeah. They're different, right?
So,
it's part of the reason why I'm trying to point it out so you guys are careful.
yeah. Yeah, I'm guilty of making that mistake. Don't pay attention.
No, for sure. And so, like,
yeah.
I want to be as transparent as possible about the pitfalls, right?
Mm-hmm.
Now, what I typically did for students who had put 4x minus 3, the idea behind this problem is, can you take the derivative, right? And so I think I ended up, if the problem was worth 10 points, I think I took away like 1 point. It wasn't like it was dramatic, but it was a loss of a point.
Yeah.
Yeah. It is. But now there's a square in there, so it's even a little bit more tedious.
For the second step, while you're plugging everything in, why did you put 2a squared plus 3a minus 2? Wouldn't it be minus 3a?
So hold on. So are you talking about
the second step? Yes, right there.
Okay, so I distributed the negative. So minus 2x squared plus 3x minus 2. Because if I didn't, it would have been written like this, and I can write it down for you. I would have gone the limit as h goes to 0 of 2a plus h squared minus 3a plus h plus 2 minus, and then I'm going to do the function notation, right? And then the next step would be to distribute.
Okay. I see it.
Mm-hmm.
Thank you.
Yeah, no problem. All right, can I move this up then so people can see this next one fully?
Yeah.
All right. Today's Thursday, right?
Yes.
Oh, good, it's the weekend. My kid's school calling me, sorry. What do you guys think? Can I start?
Yes.
All right. Oh, that should be a minus 2 right there. Okay, we okay with that?
Yes.
Okay. Oh, I'm already changing the signs. I should be careful over here. If I want to do that, then that's minus. Do you guys agree with that?
Yes.
Okay. What else can go? Looks like this can go. A can go. 2 can go. I think that's it. Oh, that could have been combined. Okay, I should combine it. So this would just be a 1. Oh, and I left out a minus 1. Do you guys agree with that? And so I'm going to be left with a squared plus 8h minus 4a minus 2h minus 1 all over a plus h plus, oops, let's do a minus 2, a minus 2, and so I'm going to get a squared minus 4a minus 1 over a minus 2 quantity squared. Yeah, Sarah, you're right. Jared, she answered your question. That's our derivative. Ooh, that's terrible. Does that make sense? So just so you know, every time an exam is always going to be a week from the day I do the review. Because I want to give you guys time to prepare for the exam. Okay, can I go next, or are you guys still copying? Remember, I could post this if you want to. You don't need to have every piece of it.
Oh, yes, please.
Okay. All right, can I move on?
Yes.
All right. All right, so in this example, then again, we're trying to find the derivative. It's kind of sad. The derivative is 2x minus 1 over 2 rad x. I just know that. But I can't do it that way. So we have to do a bunch of work. You know, sometimes you get tired of doing stuff and it's like, oh, I know the answer. But oh well. We have to do it. So the limit as h goes to 0 of x plus h squared minus square root of x plus h plus 3 minus x squared plus square root of x minus 3 all over h. That sucks. Okay. So the limit as h goes to 0 of this is going to be x squared plus 2xh plus h squared minus the square root of x plus h plus 3 minus x squared plus square root of x minus 3 all over h. And we can cancel some things, right? So 3 and 3 and x squared and x squared. And so we're going to get the limit as h goes to 0 of 2x plus h squared minus square root of x plus h plus square root of x all over h. And now I'm going to play a game. Okay? Oh, the quick way, chapter 3. Chapter 3. So for this exam, you won't know the shortcut. But to do this problem, I'll tell you 90% of my students get this problem wrong. It eats them for lunch. I'm going to break it up into two pieces. 2x plus h squared all over h. And then I'm going to take the limit as h goes to 0 of square root of x plus x all over h. In fact, what I'll do is I'll go plus and change these to minuses so that the sign's already in there. The first part's easy, right? The left-hand side's easy.
Professor, I have a question.
Yeah.
On the second breakdown, I'm not sure where you got to 2x plus h. The second to the last. On top, I see a 2x plus h squared, and on the bottom, it broke down to 2x plus h.
Oh, this should have an h. This should have an h. Yeah. Thank you. So we can see an h is going to come out, and from here, I'm going to get 2x. Oh, that's why I was sloppy. Silly me. This should be 2xh, and I put a plus in between there for some reason. That h shouldn't be there. Thank you. So I end up with 2x plus h, right, after canceling out the h's, and this is just going to become 2x. Okay, so 2x plus whatever this thing's going to end up being. Okay? And to do this, since they're radicals, I have to multiply by the conjugate, correct? And so what I'm going to do is I'm going to multiply, I want to save space, but I don't want to confuse you guys, so I'll just do it. So, you know what? Let's make my life easy. I don't care about signs. I'll just make it minus here. So this stays plus, so it's easy to conjugate with two deals. Okay, so when I multiply by the conjugate, I'm going to get square root of x plus h plus square root of x times square root of x plus h. Gee, my writing's getting terrible. Minus square root of x, and then the denominator is going to have that same piece. Right? So that's going to become x plus h minus x over h times square root of x plus h minus square root of x. And again, we're still going to have the limit. The x's are going to cancel, the h's are going to cancel, and so I'm going to have the limit as h goes to, not infinity, to 0, of 1 over square root of x plus h . Oh, shoot. I messed up, and here's where I messed up, and it's a very good, I'm glad I made this mistake, because this is where people can get so caught up. See this here? Because I put the negative out front, that needed to change to a minus sign. Okay? And if you need me to explain why that is, I can explain it to you. So this is a minus, this is a plus, this is a plus. So that's a plus. So that's a plus. Does everyone see why?
Is it because you're trying to cancel them out?
No. It's because what ends up happening is really when I made it a limit, so the minus sign is here, right? But when I move the limit in front, what really happens is I'm now going bracket of that thing. And now that negative is going to distribute. Because you
Oh, I
see,
see.
do you see how this is a positive now?
Hmm?
And this is a negative? That negative would make that negative and then turn that positive. So you have to be careful with your signs. I love it. I'm glad I made a mistake and I'm glad I caught it so that you guys could see it. And so then from here, once I apply that h is 0, I'm going to get 2 square root of x. And so my answer is going to be 2x plus 1 over 2 radical x. But when you break it up, don't forget, when you break up the limit, that negative in front changes the signs of the numerator. Okay? I'm really happy I made that mistake, actually. All right. Yeah, what's up?
You can go ahead. Whoever else was talking.
Oh. Okay.
Okay, wait, never mind. I thought someone else was saying something. Okay, so I just have a question about the formula. So, because there's like a couple different ones. There's like the limit as h is approaching 0, but there's also like as x approaches a. So as long as you have like that limit, you can kind of interchange like x and a. So like right here we have it's like find f of x, or with this one. I think I'm confusing myself more than this is actually.
So
okay, go ahead.
So let me explain that to you. So in order to use the limit as x approaches a, you need to know what the heck a is. So do we know what number we're approaching in this problem?
0, right?
No. Remember, and this is why I like to show 2.4 to my students. A is not 0. The h here is the margin of error to the number, the desired number we're trying to get to. When you go x is approaching a is the desired number you're getting to. In this problem, I don't know what that desired number is.
Mm-hmm.
Does that make sense? So there's a distinction between the two.
Yeah.
When I've used the f of x minus f of a over x minus a, I've known what the a value was.
Mm-hmm.
Here I don't know.
Okay, that makes sense.
Got it? Okay.
Yeah.
It's a good question. Okay, let me do number 4.
Sorry,
Yeah.
I also had a question real quick.
Mm-hmm.
So you know how you plug in the 0 for h on the denominator? How come you don't do that to the numerator?
There's nothing left in the numerator.
Oh, I'm so sorry. Never mind.
Does that make sense?
Thank you. Yeah.
Okay. Yeah.
So I have a question too.
Okay.
I'm a little confused with the left half, the first half of the equation, the 2x. You know how 1/2 we got 1 over 2 square root of x? What about the 2x?
Say that again?
Like, you know where it's the limit of h goes to 0 to x plus h? So the h goes down and we're left with that 2x, the first half of the equation.
Are you talking about this piece?
No, the one below it. The one below it.
Here.
Yeah. You know how we took the limit of h goes to 0, 0? And then we have the 2x. What do we do with that 2x? Finally.
Oh, so that is this first part.
Oh, there. Oh, I didn't see that part. Sorry.
Yeah. So that was this section of it, and then this section of it worked out to be.
Oh,
this
yeah.
piece. So it's this.
I thought the final answer was
plus
just
this.
the one on the right hand.
No. Yeah, that's why I boxed it here. You got it?
Yeah, I got it. Thank you.
Okay, no problem. Yeah, that's critical. I want you guys to be able to know that. Okay, good. And I'm glad I when I factored out the negative. If I wouldn't have factored out the negative, I wouldn't have had to worry about changing the signs. If I would have left it as a plus with a minus, but oh well, silly me. I must be tired today. Okay. Now it wants us to find the first and the second derivative. Okay, so with the first derivative, and here I'll tell you what the answers are. It's that, and then, oh, what's the second derivative of this bad boy? X to the third. I want to say it's 8. It's positive, but I can't remember. I want to say it's 8. I might be wrong on the second derivative, but that's the first derivative, okay? Okay, so the limit as h goes to 0 of 4 over x plus h minus 4 over x all over h is going to become the limit as h goes to 0 of 4x minus 4 times x plus h all over h times x plus h times x. So the limit as h goes to 0 of 4x minus 4x minus 4h all over h times x plus h times x will be the limit as h goes to 0 of negative 4 over x plus h times x, which is going to be a negative 4x squared. Does that make sense, or did I do that too fast? Now, to take the second derivative, I'm going to take the limit as h goes to 0 of a negative 4 x plus h squared minus, or actually becomes plus, this over h. So the limit as h goes to 0 of a negative 4x squared plus 4 times x plus h squared all over h times x plus h squared x squared is going to give me the limit as h goes to 0 of a negative 4x squared plus 4x squared minus 8xh plus 4h squared all over h times x plus h squared x squared. And so the x squared is going to cancel. I'm going to get a minus 8 x plus 4h all over x plus h squared x squared. As I apply the limit, I'm going to get negative 8x over x to the fourth, which is going to be a negative 8 over x to the third. I left out the sign. It should have been negative. Bummer. No, it should be positive. So I was right.
So the difference between first and second derivative is just like the power that it's raised?
There's also a product that happens there, so you can see. So the next one would have been a negative 24 over x to the fourth. But that's, you start seeing patterns, you know.
Yeah, just because like when you said it, like I get the one on the left, but like on the right, it's just like how did you like get there?
What do you mean? How did I get there? Every step.
Yeah, so you have like all the numbers, but just like with the x, like x plus h squared and x squared, like that's because it's a second derivative.
So in the second derivative, the function that I'm using is this one.
Oh.
So then when I take the derivative of this, I'm using the formula and plugging in there that way.
Okay.
Does that make sense?
Yeah, they're not like separate. Okay.
Russell, you see, Russell, there is no quick way. You don't know a quick way. You won't know a quick way till chapter 3. So it's also part of the reason why I'm asking you guys to give me your work. Now, let me stress how important showing your work to me is. If I don't get your work, you will get a 0 on the exam. Okay? Because your work is the proof that you've done the exam. Is that clear? All right. So
That's your last question.
Oh, yeah, what's up?
So if we were going to take the third derivative, we have to use build upon 8 over x cubed.
You build on this.
Yes.
That's right. And you can see
So
how
many
tedious that
derivatives
is.
of a
Huh?
function can you take?
How
How many derivatives of a function can you take? Can you get, say, like the 10th derivative? Or,
Oh, yeah.
Like, how far does it go?
How far can you go? It's infinite.
Yeah.
You can keep
I
going.
see.
Yeah. It keeps going until you no longer have a function.
I see.
Yeah. All right, next. This is a problem that you guys should all be able to do. So as we're approaching 3 from both sides, is this an agreement? So for me, the way I would demonstrate it is I would go from the left. And since I'm coming from the left, the critical number is 3. So if I plug in a number that's smaller than 3, that means I'm getting a negative value, correct? So this becomes negative x minus 3. And so I'm going to get 4x minus x plus 3 with this limit. And I'm going to get 3x plus 3, which will then be 3 times 3 plus 3, which is 12. Okay, then I'm going to also check it from the right. That's the positive case. So I'm going to go 4x plus x minus 3. Which is going to give me 5x minus 3, which will then be, I should show the steps. 5 times 3 minus 3, which is 15 minus 3, which is 12. And so this is 12, this is 12, so this is 12.
Professor?
Yeah.
Why can't you just plug it in the 3?
Cool, because we're approaching it from 2 sides, correct? And since we're approaching it from 2 sides, the absolute value as I come from a value on the left is going to have an absolute value that's negative. And so we need to make sure that our answer ends up being the same. I don't know if you watched the last lecture where I talked about absolute value and how when you approach a function with negative values and positive values in the absolute value, it impacts what the definition is. And so really what I was testing in this problem is to see, do you see that this should be a 2-sided limit that confirms the answer by looking at the 2 1-sided limits? Does that make sense?
Yes.
Okay. Horizontal and vertical asymptotes. I showed you guys how to do that. I put it on the exam. So to find the horizontals, x is going to go to infinity, and we need to show x is going to negative infinity. So I'm just going to do it the lazy way. I'm going to go x squared divided by x squared minus x divided by x squared over x squared minus 3 over x squared plus 2 over x squared. So that shows me that I'm going to get 1 minus 1 over x over 1 minus 3 over x squared plus 2 over x squared. But the limit is still there. So that tells me that it's going to be 1, right? So we know that we have a horizontal asymptote at y equals 1. Now, I need to confirm that going to the negative side is also um, um, checked. And the process ends up being the same, unfortunately, for this problem. I should come up with a problem where the answers are different, which is totally possible. So applying that, I'm going to end up with the limit as x approaches infinity of 1 minus 1 over x over 1 minus 3 over x squared plus 2 over x squared, which is again 1. So that only has one horizontal asymptote. Now we need to check for vertical asymptotes, and for vertical asymptotes, I'm going to see if I can clean this up a little bit before I try to do it. Let's see, what's that going to be? Minus 1 and minus 2. So I'm going to look at this guy. Oops, not that guy. This should be a minus 2. Right? Because at x minus 1 we have a whole since they cancel. Correct? So what I'm going to do is I'm going to check a one-sided limit. I don't know why that happened. The limit as x approaches 2, and let's go from the left. So if I'm approaching from the left, it's a number that's smaller than 2 that's going to be plugged in for x, correct? Right?
Yes.
So that's going to give me positive infinity. That's what I'm checking for, that you have the right limit. And therefore, x equals 2 is a vertical asymptote. Does everyone see how the limit is positive infinity? Ooh, positive infinity. It should be negative infinity. Dang me. Should be negative infinity. Does everyone see why it's negative infinity? Yes?
Yes.
Okay, cool. All right.
It's going to be negative.
Number 6, or number 7. This is, again, that definition of absolute value. So I'm going to divide everything by x to the third. Correct? The negative is there because x to the third became x to the sixth, but we're approaching from the negative side, and since we're approaching from the negative must come out in front. So I'm going to get a negative root of 1 minus 1 over x to the fifth over 1 plus 1 over x to the third. The limit as x goes to negative infinity. This will go to 0, this will go to 0, and so my answer is negative 1.
How did you divide those by x to the 6th?
My bad, it's not, it's 2. Because that should be a 4. What's that, I'm sorry?
How did you on the first step? 4x to the 6th, and then you put it all over x to the 6th.
Mm-hmm.
It's just how do you get there?
So what I did was I multiplied both top and bottom by 1 over x to the third, correct? Okay. But when x to the third gets put into a root, it has to be x to the sixth, because what's the square root of x to the sixth?
Third?
Yeah. Because what's the root power? It's 1/2, correct?
Mm-hmm.
So what's half of 6?
3.
There you go. You okay?
I think so.
So what this ends up being is really it's absolute value of x to the third, because we don't know if we're dealing with positive or negative. So in this case, we were dealing with the negative, and that's why it became negative x to the third. That's why the negative is in front of the root. So anytime you're going into a root, just double the exponent. If it's a square root. Got it? All right. Can I go to the next one?
Yeah.
Right,
You're posting this, right?
Yeah.
Yeah. So
are you guys? How are you guys feeling about this test?
Scared.
Oh no! Don't be scared. It'll be okay. It'll be so much fun. All right. Oh, I don't even want to do this problem.
Oh, this one's fun.
You guys can do this problem, right?
Yeah.
I mean, we did enough homework problems like this. Do I need to do this one?
No.
Does anyone want me to do this? Ray, I'm on my third cup of coffee. That's awesome. Thursday. So you have a week. Okay. I'll just do one of them. Not many questions. I don't know. Less than 20 for sure. Probably closer to 10. Why do you laugh?
Because then each question is worth like way more.
But then you have way more time for each question.
That's true.
So I'll do this bottom one. So remember, it's an interval. So I'm going to go 52 1.001 minus 0.83 times 1.001 squared minus 52 times 1 minus 0.83 times 1 squared, all over 1.001 minus 1. Okay? And whatever that ends up being, that answer is pretty much the same as the estimate that you're trying to do. Right? But for each one of these, all you're doing is finding the slopes. And that's the process to find the slopes. Is there any questions on that one? No?
No.
Okay. All right. So here I'm asking for you to use the limit laws. I'm not going to be picky about the limit laws. So really what the limit laws say that what I can do is go like this, right? Right? And then what I can do is go the limit, this is 1, 2, the limit as x approaches 2 of 2x squared plus 1 over the limit as x goes to 2 of 3x minus 2. And let me make that bigger. And then at this point, I can substitute in for both. So I'm going to get 2 times 2 squared plus 1 over 3 times 2 minus 2, which is going to give me 8 plus 1 over 6 minus 2. So that's 9 over 4.
So would we lose points if we just went straight to substitution?
I'm asking you to use the limit laws. So yeah.
Okay.
That's why, like, when I give my directions for my exams, I'm specific. Does that make sense? Yeah, I'm specific. That's why that one problem, I'm like f of a.
Uh-huh.
I'm being specific about what I'm looking for. So like in this problem, just so you know, this is the answer, right? Let's say this problem was worth 10 points. If you just went straight to the answer, you get 1 point. You think that's devastating?
Yeah.
It's pretty devastating. You just lost 9% on your exam because you didn't show your steps.
Yeah.
So answers are cool, but more important than answers are steps. Okay?
Question. You don't have to square root that because of like the square root. It kind of just.
Oh, that's right. Thank you. So it should be 3 over 2.
Okay, cool. Thanks.
Yeah. All right, last one. Oh, Lord. What? I'm human?
Yeah.
Look, that's one thing you're going to get from me, man. I'm always going to be authentic with you guys. All right?
That's cool, man.
I mean, we're human, right? Like, I love math. But if there's some times where it's like, dude, can I just take a nap? You know, what are we going to do? Will we get partial credit if we mess up somewhere along the line? Yes, of course. That is why I want you to show me your work. And that is also why if you don't submit your PDF of your work, I'm going to give you a 0 on the exam. Because I want proof that you've done the exam, for one, and for two, if you make mistakes, I can still give you partial credit, because that's important to me. We're trying to learn, and on that learning journey, there's some things that we know and some things that we might mess up on. But the things that we know, we should get credit for, right? So, yeah. Thanks for pointing out about the square root. I don't. I'm tired, I guess. All right. Let me do this last one, and then we'll call it a day, unless you have some questions. Wow, you're the third person to ask that same question. I haven't had a cup of coffee today yet, so that might be it. So the shortcuts you cannot use until chapter 3. Now, if you know the shortcuts and you want to check your work to confirm that you're right, by all means do that. But I want to see the work the long way. Does that make sense, America? Okay, cool. There's no harm in using knowledge you have to confirm your work. That's cool with me. All right, let me do this last one. If I factor out, will that help me? Of course I do this to myself. All right. So the limit as x approaches -1 of x over x plus 1, that tells me I can't directly substitute. I have to do one-sided limits. Okay? Do you guys see that?
Yeah.
And so I'm going to go the limit as x approaches -1 from the left.
And so why do you have to do double-sided limit? Or
Or
one-sided? Like, why can't you just put in -1?
Go ahead, put it in. What are you going to get?
Well, yeah, it'll be like it won't exist.
Yeah, no, that's not. We can't have that. We want to. We want to.
Then we do the two-sided limit.
Yeah, if it ends up undefined by directly plugging in, we need to check each sided limit, because you're probably going to end up with DNE, which I'm sure Carol's probably right. In fact, I know it's DNE because one's going to be negative and one's going to be positive infinity. The one that I'm doing right now is going to be negative infinity, and the other one's going to end up being positive infinity. That's going to give me DNE. Undefined is not DNE. Don't make a mistake. They're totally different things. Okay? Undefined just means we don't know what the heck it means. Does not exist means it doesn't exist. they're different things, right? It's like us talking about the fourth dimension. We know mathematically that the fourth dimension works. Physically, we don't know what it means, and so we can't say that it doesn't exist. We just don't know what it is.
Uh-huh.
Does that make sense? The distinction between the two? So, okay. So this one's going to end up being negative infinity. Do you guys agree?
Mm-hmm.
Right? Because I'm going to end up with a negative, nope, this one's going to be positive infinity. Do you guys see why it's positive infinity? Because the top number is going to be a negative number, and then the bottom is going to be a very small negative number, which is going to explode it to positive infinity. Right? So if I use like a negative 1.0001, the denominator would be a small negative 0.0001, but negative over negative yields a positive infinity. Now, as I go the limit as x approaches negative 1 from the right, I'm going to end up with negative infinity. And the reason I end up with negative infinity is on top, I'm going to end up with negative 0.9999 over 0.0001. They're opposite signs, so that's going to give me that negative infinity. These do not agree, and since they do not agree, this is D and E. Just so you know, a ton of people plug in directly and put undefined, and they get undefined as an answer, and they get the whole problem wrong. Someone asked if I've studied quantum physics. Yes, like I said, I taught physics for 10 years. Quantum is actually very, very interesting because Newton's laws don't work, which is a trip. There's actually a very cool thing. If you guys are into physics, there's a cool movie you should watch. Einstein's Big Idea. It's actually super cool. It's about him and how he discovered relativity and things like that. And then from there, that's where quantum came from, right? But yeah, it's cool stuff. Are you a physicist? Are you studying physics? Oh. Well, it's cool stuff. You guys should study physics. I think physics is rad. But that's what the exam is going to kind of look like. Yeah, any questions on it?
In regards to uploading or showing our work, you mentioned like a dash cam or that we can
Here, I'm going to stop
notes into
recording.
PDF so that we can.
Yeah, let me
I missed
stop
that last
recording.